Okay, so welcome everybody to the first DaSCI seminar of this new year, 2025. Today's speaker is Professor Kenneth Sörensen, who is going to talk about metaphor-based metaheuristics and critically analyze specific cases where the lack of originality and flow metaphors have been exposed. He is a research professor at the Faculty of Business and Economics of the University of Antwerp, and founder of the Antwerp Research Group, which focuses on applications of operations research. Kenneth Sörensen is considered one of the world's leading experts in the field of metaheuristics, and he is the founder and current coordinator of the Euro Working Group on Metaheuristics, the largest online platform for researchers in this field worldwide. I want to thank again Professor Sörensen for very, very kindly accepting our invitation. And whenever you are ready, the floor is all yours.
Thank you very much. Thank you for having me here. I'm always a bit ambiguous about giving this talk because on the one hand, I enjoy talking about this topic. It's something that really interests me. But on the other hand, I hope that one day there will come a time when I don't have to talk about this topic anymore. Because metaphor-based metaheuristics, as I see it, have been a problem in our community in the optimization field for quite some time now. And well, I don't see the problem getting any better. I think on the contrary, things are getting worse. We see more and more metaheuristics based on metaphors. And I'm critical of that up to a point that now I consider metaphor-based metaheuristics to be to optimization what something like homeopathy is to medicine, or astrology to astronomy, or numerology to mathematics, or creationism to evolutionary biology. So metaphor-based metaheuristics has turned itself into a really poor junk science. It's almost like pretend science, people pretending to do research, writing papers that look like real research papers, but are basically just pretend research papers. And that's what I'm going to talk about today. If you think this is a small phenomenon, must be limited to a few people, let me start with this, a small quiz. So I'm not sure you know this database, but it's the Stanford and Elsevier list of the most cited researchers, right? The most cited researchers, there is a lifetime database, and there's also a 2024 database. So this is for the past year. And my question on this data is, there is a subfield for artificial intelligence, which is called AI and image recognition. And my question is, in 2024, who was, according to this Stanford and Elsevier list of highly cited researchers, who was the most cited researcher in the field of AI and image recognition? And at the same time, this person is the third most cited author worldwide in any domain. So if you want to maybe guess who that author is, and you might think it's a Nobel Prize winner, the founder of large language models. Is it the people at Google who wrote the Transformers? Jeffrey Hinton, I was thinking about. Is it maybe Jan LeCun, famous at Meta for being the research director there? I can tell you those people, they are in the top 10. But in fact, the most cited researcher in the field of artificial intelligence in 2024, and the third most cited researcher in the world overall in all fields is this person. I blurred his name. I have some not so nice things to say about him. I'm not here to name people or shame people, so just demonstrate the extent of the problem. So I blurred most of the names in my talk. They're not so difficult to find, but okay. So it's this person, and you may ask yourself, what is this person famous for? Well, I'll tell you, this person is famous for his optimization algorithms. More specifically, he's the inventor, the creator of the gray wolf optimizer, an algorithm based on the behavior of gray wolves, the moth flame optimizer based on the behavior of moths, whale optimization algorithm, the dragonfly algorithm, the antline optimizer, and this list goes on for a number of pages. So he invents these new algorithms. That is what he does. And this person is the third most cited researcher in the entire world across all domains. Let me say, I find that particularly bizarre. I find that very weird. Why? In a few years ago, in 2022, a paper appeared by some very well-respected researchers in Brussels. And the paper is called Exposing the Gray Wolf, the Moth Flame, the Whale, and a number of other algorithms. You recognize them from the previous slide. So this paper, basically, what did it say? Exposing these algorithms? Well, the main conclusion of this paper was that all the algorithms that the authors analyzed, so they went on to look at the algorithm, and so what is the new ideas in this algorithm? What is the contribution of these algorithms? And their main conclusion was none of these algorithms proposes a single new idea, right? So that's what I think is completely bizarre. The third most cited researcher in the world, the most cited researcher in the field of artificial intelligence, and all of his contributions, and he didn't bring a single new idea to the state of the art. Let me call that strange, right? So, to quote this paper a bit more, what did he do? Well, he used variations of the same algorithm components that were in the literature for years, and sometimes for decades, and just repackaged them into new metaphors and published them as new. For example, the gray wolf optimizer, these authors show, is nothing but a variant of the particle swarm optimization algorithm. But except for calling things particles, he calls them wolves. And instead of attracting particles, he calls it, the wolf moves towards the prey, right? Voila, new algorithm. The moth fly, same thing, right? Instead of a particle, it's a moth. Instead of attracting other particles, the moth moves towards the flame, for example, etc., etc., etc. So that for me was something which is very difficult to fathom, difficult to swallow. The fact that the most cited author in the whole field of AI has done nothing to advance the literature on artificial intelligence, except for renaming existing algorithms using different types of metaphors. That's strange. Moreover, also interestingly, the authors went a bit further and went to look at the metaphor themselves. So the author claims, I have created an algorithm that mimics the behavior of gray wolves as they hunt for prey. So what did the authors do? They went to look at those algorithms. They went to look at the behavior of wolves, what is written about that, and found that the algorithm actually is nothing like the behavior of wolves. So even the metaphor is not used correctly in this case, right? So there's lots of irrelevant details about wolves, but the facts that would be relevant for the purpose of designing an optimization algorithm are not there. The irrelevant facts, there's lots of them, pages and pages about wolf behavior, but nothing interesting for the design of algorithms. So many years ago now, around 2010, 2011, I gave a talk when I saw that more and more metaheuristics were being based on metaphors. And yeah, that is what I will talk about today. So I will talk about what I call M&Ms, metaphors and metaheuristics. and they're a bit like their candy M&Ms. They're colorful, they can be funny, but they're very unhealthy, and you should never eat too much of them. So I'll talk about what they are, why they are problematic, and also a little bit about what can be done about them and what is being done about them. Okay, let me take you back a bit to the start. My field is optimization. So here is the most simple form of an optimization problem I can write down. So we have some decision variables X. These are constrained by a domain large X. And then we have an objective function f of X that maps the decisions onto a real number. And the better the solution, the higher the objective function value. Yeah, that is what we're looking for. So what we're actually looking for is X star, the so-called optimal solution to the optimization problem, the best solution that is possible for our optimization. Now, many optimization problems in real life are particularly nasty, difficult to solve. So the question is always, how do we do that? How do we find the optimal solution X star? And yeah, that's what the field of optimization is about. So we're looking for algorithms, trying to find better ways to find or approximate the optimal solution. And there's two ways of doing that. One is using exact methods. An exact method is an optimization method that comes with a guarantee of finding the optimal solution, which is very nice, but very often is not practical. These methods are too slow, they take too much time, take too much computer power. So in that case, we resort to using heuristics. So heuristics are optimization methods that are not exact methods, so they don't come with a guarantee of optimality. So up to now, I've been talking about problem-specific methods. So, for example, the Dijkstra algorithm for the shortest path problem is an exact method for the shortest path problem. Vogel's approximation methods. I don't know if you've ever had a course in operations research, but you might have had something like Vogel's approximation method for the transportation problem, or a nearest neighbor algorithm for a traveling salesperson problem. Those come without a guarantee of optimality, and those are then heuristics. Now, if we don't have a heuristic for our problem, we need to develop one ourselves. And one way of doing that is to look at so-called meta-heuristics. Meta-heuristics are, here's a definition, meta-heuristics are high-level, problem-independent frameworks that give you a set of ideas, guidelines, strategies, more or less consistent way to develop a heuristic optimization algorithm. And there are many examples like taboo search. Taboo search, you should think of taboo search as using memory of the search to guide the search in the future. You've done a few things in the past. What can you learn from that to steer the optimization in the future? Or iterated local search. I'm not going to go through all of them. I don't have time for that, but there's lots of different meta-heuristics which introduce new ideas, new concepts, new guidelines, new strategies that you can use to develop a heuristic optimization algorithm. Now, some meta-heuristics are based on a metaphor, and historically there's things like simulated annealing, which is based on the cooling process of a crystalline solid like glass or metal. There's genetic evolutionary algorithms, which are modeled on Darwinian survival of the fittest. There's ant colony optimization, which is modeled on the behavior of ants. And each of these introduces new algorithmic concepts that are generally applicable. Simulated annealing, for example, introduced random local search, small changes, and then a cooling schedule to guide the search out of local optima. Right? Genetic algorithms, evolutionary algorithms, they introduced the use of recombination, combining different solutions into new solutions and selecting them with a certain probability that is a function of how good the solutions are. An ant colony optimization introduced a constructive process where you have several construction processes working at the same time, and they communicate with each other about how the construction went and which are the good elements to add to the solution. So all of these, let's say, historic metaphor-based metaheuristics introduced new ideas to the literature, for which reason they're very interesting, and we learned a lot from them. The problem now is that we see more and more metaphors being used as basically the only motivation for the development of novel metaheuristics frameworks. We see papers in which there is nothing new except for the new metaphor. I put the novel between quote marks. It's funny, almost all of these articles have the word novel in the title, but the only thing novel about it is the metaphor. It's a paper using frogs as a metaphor, and the only new thing is it's frogs, or it's a paper that uses bees or wasps, and the only novel thing is the bees or the wasps. So in my, I argue that these actually are not novel papers at all, shouldn't be treated as such. I'll give you another quiz. Here you see a few examples of metaphor-based metaheuristics. One list is real, the other list is fake. I invented it myself, and I want you to think about which one is real, which one is not. So the waggle dance algorithm, based on the behavior of bees that dance to each other to transmit information. The doll maker optimization algorithm, based on the way the traditional art of making dolls, some boys play with. The green heron optimization, based on the behavior of the bird called green heron. Water wave optimization, based on water waves. Mine blast optimization, based on explosions in mines that shrapnel pieces float everywhere. And the Lorentz transformation optimization, based on the Lorentz transformation from physics. That's list one. And then list two, the flying elephants approach, based on flying elephants. The Botox optimization algorithm, based on the plastic surgery of Botox injection. The Egyptian vulture algorithm, based on the bird, Egyptian vulture. Flower pollination algorithm. The imperialist competitive algorithm is based on how nations compete with each other and conquer each other. And the Big Bang, Big Crunch optimization, well, based on the Big Bang and the origin of the universe. So I'll give you a second to think which of these is real and which one is fake. Yeah. Normally I let people raise hands, but that's a bit impractical here. I'm going to tell you actually both lists are real. I didn't invent any of these algorithms myself. All of them have appeared in the literature published as journal articles. There you go. So, and then we see things like this in the serious optimization literature, in the intelligent water drops paper. The amount of soil on the edges of the iteration best solution is reduced based on the goodness quality of the solution. From the green heron optimization algorithm. The bait helps the green heron bird to catch a prey, and thus the solution set elements remains constant. Okay? Like, if you know what that means, you are smarter than me, because I have no idea what they want to say here. Or in the cuckoo search algorithm, the aim is to use the new and potentially better solutions, of course called cuckoos, to replace the not so good solutions in the nests. What's a nest? I mean, we're optimizing here. Mine blast algorithm. This population is generated by a first shot explosion producing a number of individuals, shrapnel pieces. And my personal all-time favorites from the Lorentz transformation optimization. The objective function was regarded as invariant to the reference frame, something like a transcendental entity in a space-time. And remember, we're still talking about an optimization algorithm here, something with solutions and local search maybe, or so in 2012, I published a paper on this, my most cited paper, Metaheuristics, the metaphor exposed. What did this paper basically say? It said, well, a metaphor is not enough to motivate a novel method. It's not because you have a new metaphor that you have a new method. So there should be something more. You should contribute to the algorithm state of the art, not the metaphor state of the art. So most novel methods are not novel at all. They're just old methods with new names. And you shouldn't do that. You should not change the vocabulary. You should not call a solution a bird or a bee or a plant or a doll maker. Don't do that. It's confusing. It makes it very difficult to compare existing methods to see where your method is new, etc. So don't do that. And of course, methods should be tested using established protocols. So did that stop the flow of Metaheuristics and metaphor? I can tell you the answer is no. I don't have any statistics, but if we look at the evolutionary computation bestiary, this is a list of a lot of metaphor-based metaheuristics that some colleagues of mine are doing. Well, this list keeps on growing and growing and growing, and I don't see that the pace at which it's growing is slowing down. So this starts at A with the African buffalo optimization, the Al-Biruni optimization, I don't know what Al-Biruni is, Algae, Alibaba and the 40 Thieves, etc. And you see some of these papers are very recent. The Al-Biruni, for example, is from 2023. The American zebras, did not know they had zebras in America, but okay. Also from 2023. So the papers keep coming and coming and coming, and it goes all the way from A to Z. Some more zebras here, and even zombies. I think that's a nice ending of the list. So the list keeps growing and growing and growing, and all of these papers basically just present a new metaphor without explaining what is new about the method that they're presenting. So what's wrong with that? Why do you bother about that? Why don't you just let everybody do the research they want? Well, I think for once it's basically junk science. It's not real science. Nobody here there's no contribution to the state of the art with these algorithms. As I mentioned many times now, a new algorithm, a new metaphor doesn't mean that you have a new algorithm. It just means you've put different names on things that have existed for a long time. Maybe in the very small chance that you have invented something new, how could we tell? Because you don't call your solutions solutions, you call them waterways, or you call them light waves, or etc. So the use of the metaphor language makes it difficult to see what is similar or different to existing algorithms. So it's junk science, but it appears in serious journals with knowledgeable people in the boards. Strangely enough, sometimes also accept these junk papers, which draws resources away from serious research. And how can outsiders, like young researchers, for example, practitioners, people in other domains, how can they distinguish a paper in optimization that is a serious paper from a paper that just proposes a novel method? There is no way to do that. So it's bad for young researchers. It's bad for the way we talk to practitioners. It's bad for everything. And personally, one of the worst things is it just makes us all look bad. It radiates, as I try to put it nicely here, it radiates poorly on the entire field of optimization. You tell people, I'm in metaheuristics, oh, I know the squid optimization algorithms. Yeah, that's not really what I'm doing, right? To put it a bit more bluntly, it makes all of us look like a bunch of idiots. If this is our field, then yeah, I don't really want to be in that field. And finally, because it's such bad science, it also attracts bad actors and encourages unethical publishing. And I'll give you some examples later in the talk. But first, I'm going to tell you how to write a paper on metaphors and metaheuristics. It's very easy. It's a trivial exercise, especially if you use ChatGPT. You can write and publish a paper. You can write it in an afternoon and then publish it. If you go to MDPI journals or something like that, you can publish it in 3 weeks. So in 3 weeks from now, you can be the proud author of a metaphor-based metaheuristics. I'm sure you can do it, but please don't, of course. So the metaphor-based metaheuristics papers are always the same. So first is the claim that a large number of metaphor-based methods exist, but of course, there's room for at least one more. Give you an example from the Gray Wolf Optimizer papers. This is a quote from that paper. And there's lots of swarm intelligence techniques proposed so far, but no technique that mimics wolves, the Gray Wolves leadership, right? So, okay, this is why we decided to develop this new algorithm based on wolves. There is no algorithm based on wolves, so here is an algorithm based on wolves, okay? Then you go on to describe how wolves do things, even if you're lying a bit here because you don't really know anything about wolves. But anyway, you need to talk about wolves for a long time and also put some pictures of wolves in your paper. That makes your papers look more serious and more wolf-based here. Okay, and you see, so this talks about how wolves sleep, who makes the decisions. There's alpha wolves and beta wolves and etc., etc. And this goes on for pages and pages. Not interesting for any, maybe for biologists, but not for optimization. But this always goes on for a long time. And then you describe an algorithm that supposedly mimics that process. But you should remember to reformulate everything in the vocabulary of the metaphor. So rather than talking about solutions, you talk about wolves here, right? And if you talk about solutions combining together, you say, oh no, there's wolves hunting prey or something like that. Huh? So you change all the vocabulary, you change the words. Okay. For example, we suppose that the alpha, the beta, and the delta have better knowledge about the potential location of the prey. Therefore, we say the first 3 best solutions, therefore, obtained so far and applied the other search agents, and also wolves, to update the positions, etc., etc., etc. Okay, so you pretend it's all wolfish, and then you basically develop a standard algorithm, or you copy a standard algorithm using things that you find elsewhere, things like local search, crossover, particle swarm, etc. Things like you see here, the search process starts with creating a random population of gray wolves. This is just a random population of solutions, right? That's nothing new here, etc. Okay? So this is how you do it. A large number of methods exist. There's room for one more. Wolves, talk about wolves a lot, and then an algorithm using standard components, but you describe it in wolf terms, okay? And then you test it on a few simple problems and claim that it is very performant. There's a few engineering problems that are typically used. These are trivial problems that you could solve using any randomized method, but Of course, your method, the Wolf method, can also solve it, and then you compare it to other metaphor-based metaheuristics, and preferably lots of them. They all solve the same simple problems, so it's very easy to compare your algorithm to lots of other algorithms. Okay, so this is your paper, right? Once you've done that, you need to advertise. Right? It's important that your paper becomes known in the field of metaphor-based metaheuristics. So you create a Wikipedia entry for your paper. Try not to get it removed because some Wikipedia editors are a bit strict on that. You create your own webpage, like the one we saw with the Grey Wolf optimizer, etc. And also importantly, in your paper, make sure to include a table like this, where is lots of other metaphor-based metaheuristic methods, and you compare yourself to them. So if you compare them, you also cite them, and then hopefully they will do the same. Next time they invent a new novel method, they will cite you back, and you will get lots of citations. This will work. And then there's step 3, because how do you publish such nonsense, right? How do you publish such, something which is not new? Well, here's your publication strategy. At first, you can try a regular operations research journal, but that's becoming increasingly difficult because these journals, by now, at least most of them know what this is about. They will just reject it. But you might be lucky if you have a lazy editor treating your journal. He might send it to 2 or 3 of your friends who are also in the same subfield, and they might accept it, and you might weasel your way into a regular operations research journal. But this probability is increasingly small. What you can also do is try an application-oriented journal. For example, you develop the Weasel optimization algorithm for planning of, I'm just talking out of my head now, the planning of the production of wheat, and you send it to an agricultural journal, because these people in the agricultural journal, they don't know what a serious optimization is and what a not so serious optimization algorithm is. So they might accept you. So we see more and more of these novel methods focusing on a specific application domain and then trying to get into the journals of that specific application domain. They should be rejected, of course, because these are not agricultural, this is not agricultural research or medical research or whatever, it's optimization research with an application in these domains. But okay, sometimes it works. And if you can't do that, then you can always go for a crap journal, something like Nature's Scientific Reports. I don't know if you know that journal. They now publish lots and lots of these metaphor-based metaheuristics. Nature, I think this is a scandal, by the way, because nature.com is the website of the journal Nature, which is, of course, a very highly regarded top journal. Everybody looks up to that, and they allow the name Nature to be abused by the journal called Scientific Reports, which publishes basically everything you send to it. That's so I think this is a scandal. I don't know why people allow this to continue to exist, but okay, there you go. You can, if you want to publish your metaphor-based metaheuristic, Scientific Reports, that seems to be the go-to journal at this moment. Okay, so now you know how the paper is, how to write a metaphor-based metaheuristic paper. I would also like to show you a few things that really go wrong in this domain. You see, it's too easy to write such a paper. So it attracts a lot of bad actors, people that try to circumvent the regular review and the regular academic process. And I'm sure this is not unique to this domain, but in the field of optimization, metaphor-based metaheuristics are really setting bad examples in terms of how to do academic research. Let me give you a few examples here. This is just one random paper that I took. Literature Research Optimizer, a human-based metaheuristic based on how researchers do a literature review. Makes no sense at all. Published in this journal Springer Nature, but this paper has 102 citations. I don't know if you've ever written a paper that had 102 citations. If I ever write a paper with 102 references, it's a literature review, but not in metaphor-based metaheuristics. 100 citations, 150 citations is actually quite standard. Of course, that increases citation count a lot, but it's not illegal, of course. What I would call silly citations. The effect of the data set size and the process of big data mining. This paper here, International Journal of Heat and Mass Transfer. A bit further in this paper, they make the following statement. Machine learning has attracted much attention in many scientific fields, such as chemistry, physics, materials, and so on. Okay, so this is the statement. Machine learning has attracted much attention in many scientific fields. Which papers do they cite to support this statement? Well, the Greylag-Goose optimization algorithm appeared in 2024, and the Puma optimizer, which also appeared in 2024, both by the same author and some friends. I mean, this general statement, machine learning has attracted much attention. Why would you support that with a paper on a novel metaphor-based metaheuristic that models on the behavior of geese or on pumas? That doesn't make no sense at all. So where does this citation come from? Fake results. It's very hard to prove that results are fake because, yeah, problems are not that difficult. So the only way to establish fake results is when you re-implement an algorithm or when you can somehow mathematically show that the results are fake. One time in which somebody did manage to prove that results in the literature were fake was here. This is about harmony search. Harmony search is a metaphor-based metaheuristic based on how people play music. I say supposedly based on how people play music because the algorithm is nothing like people playing music, but okay. Decision variables are called musicians, and generates a solution is now plays a piece of music, a note is a value, etc. Harmony is a solution, etc. So all the words are changed again. Harmony search, if I search for harmony search this morning, I found 75,000 papers on harmony search. Again, which is weird because many years ago, I think it's already something like 7-8 years ago, Dennis Wayland showed that harmony search is simply a special case of evolution strategies. And evolution strategies is something from the late 1970s, early 1980s. So 30 years older than harmony search. Dennis asks himself the question, how could such a method become portrayed as an innovation without people asking any questions? And even after the questions are asked, there's still lots of people just think, oh yeah, we're doing harmony search. Okay, very weird. Now, in a very rare event, the author of the harmony search algorithm actually responded to the critique of Dennis Wayland using this. He wrote a paper, commentary on this paper, and this, if you've never read it, it's really worth reading because it's one of the most unhinged pieces of scientific writing that I've ever read. His argument for copying the evolution strategies algorithm says, I didn't know evolution strategies and I could not find it on Wikipedia. Okay, maybe not the best argument. And he also says, the author of evolution of Harmony Search says, well, you cannot just claim that it's that Harmony Search is equal to evolution strategies. You should use mathematical proof or numerical results. Okay. Dennis Wayland says, challenge accepted. And in a new paper, Critical View on the Harmony Search Algorithm, Dennis Wayland actually shows that mathematically, Harmony Search is completely equivalent to evolution strategies. So QED, there is no existence reasons for the Harmony Search algorithm. It should not exist because it already exists. It's just a new name. Okay, but then it goes a step further, and it turned out that the author of Harmony Search had written a Harmony Search algorithm to solve Sudoku puzzles. And he shows how Harmony Search is really good at solving Sudoku puzzles. Dennis re-implements the algorithm and theoretically shows that the probability that the results reported in the Harmony Search paper are true, the probability is less than 10 to the power minus 100. So there is basically zero probability, Mr. Harmony Search, that your Sudoku algorithm actually produces the results that you report. Bam. And also, when I re-implement your algorithm, I also find the number of times that I find the best solution, the one that you find, is 0 across the board. So you've been lying. So, and my guess is this is not a unique case. There must be lots of cases in which results are faked or at least exaggerated. It's just hard work to prove it, and most people don't find it worth of their time. And I think I want to show one more thing. I talked about the gray lag goose optimization algorithm. I think you remember it from the silly citation, where this paper was used to make the claim that machine learning is used in many different fields. This paper caught the attention because it was published in 2024 and immediately had a rather strangely high number of citations. Why would you cite this paper? There's nothing particularly interesting in this paper. So if you look at it now, it has 140 citations, even though it's from 2024, right? And it's inspired, it's cited by the hippopotamus optimization algorithm, the flood algorithm, the catfish algorithm, right? The friends in the field, the friends in the bubble that cite each other. But if you look a bit further in the, you see here it's 140 results. But if you look a bit further in the reference or in the list of papers that cite the gray lag paper, the gray lag goose paper, these caught my eye here. So this is papers appearing in the GCSIS.org, GCSIS.org. What is that, the GCSIS.org? It's the Journal of Computational Science or Computer Science and Information Systems. I don't know if you've heard of it, but it's basically a completely fake journal. And this is one of the papers that cite the gray lag goose paper. It's on highway overtaking highway overtaking. These authors that you see here, these people don't exist. And the paper is basically just an abstract, which I think is machine written. Makes very little sense. So it's an abstract, some keywords, and then lists of references, I think about 150 references, 90 of which have the name of the author, the first author of the gray lag goose paper. So in one fake journal here, our author of the gray lag goose paper gets 90 additional citations in his Google Scholar profile, because, right, Google Scholar apparently does not have a blacklist for these types of journals. So, well, you can say what you want. I don't have no proof that the author was himself involved in buying these citations, but at least it's very suspicious and it requires some further investigation. And I must tell you, if you spend some time looking at these metaphor-based metaheuristic papers, yeah, it's very easy to run into things like this. So it is a bit of a rabbit hole. It is a bit of a bubble, and it attracts a lot of bad actors, a lot of not so ethical scientists. So what can we do about it? And I'm almost rounding off now. Yeah, we can write pamphlets, manifestos. We can do the bestiary, the metaphor exposed. The elephant in the room, I'm going to talk about that. We can expose these methods one by one, as was done by the gray wolf method or with the harmony search methods, etc. But that's time-consuming. That's not really what you want to do. I think it's important that editors across the scientific world, start to act as gatekeepers. These papers should no longer appear. There's too many disadvantages of them appearing. So I argue that we should have explicit editorial policies to have these papers desk rejected as quickly as possible. Of course, if you are asked as a reviewer, you can write a harsh review report. Also, maybe we should start refusing to publish in journals that still publish these papers. At least I do. Some journals I stopped publishing in because they still publish metaphor-based papers. I don't review for them, or at least not serious reviews. I write very short review reports. Okay, this is obvious crap, and maybe it's time for a boycott. I don't know. That's something that's up for discussion, but I think we still need action here because things are going in the wrong directions. Editorial policy changes are definitely a way to go for me. The first was the Journal of Heuristics that has a very extensive argumentation about why methods should not just be published. The metaphor-based metaheuristics should not be published unless they are translated into a metaphor-free language, and then we decide based on that whether there is anything new. We've written a paper with some people called Metaphor-Based Metaheuristics, a call for action, the elephant in the room, in which we invite editors to add an explicit policy to their journal, that the journal will not publish novel metaphor-based metaheuristic papers unless you use standard optimization technology, brings novel concepts, etc. So the usual requirements of a scientific contribution. That's the things we can do. I hope at some point it will start to have some effect because, as I said, I have a feeling that the situation is only getting worse. Maybe there will come a time when the bestiary will stop growing and people will see that this was some kind of a bad nightmare that we got out of. But yeah, I'm not very hopeful in the short term. So to conclude here, I say metaphors should be considered harmful, and they're cheap and easy to come by, as is said in the Journal of Heuristics editorial statement. And the use to window dresser method is not acceptable. So metaphors can be used, but use them as inspiration, never as the motivation for the algorithm. And always express your method in a neutral algorithm vocabulary so that everybody it brings something new to the field. Thank you very much. I think I'm done. So ready to answer any questions you may have.
Okay. Well, thank you very much, Kenneth, for this amazing talk. Well, now it's time for questions from the audience. So as usual, feel free to write your name in the chat and I'll give you the turn to speak. Any question from the audience? Danny Molina. So go ahead, Danny, please.
1 second. You see me?
Yeah.
Okay. Thank you, Kenneth. It's a very great talk. I work also in Metaheuristics. Even I have to refuse as reviewer some new Metaheuristic of the same well-known author that I can get. And I just finished an article. I have an archive that I talk about paradox, because when usually in a research field that there is so many proposals, you suppose that the research field is good, is in good state. But here, so many proposals make noise. So the thing, I have a question about how could, what about that? As you say, they have some constructive paper that can analyze several metaheuristics, say there is, but it's like try to talk to a stupid. It's impossible because there are so many proposals that they are bigger that you can refuse. But maybe we should more focus on the, well, I don't know what you think, on the experimental section, maybe, because if there were very well experimental section that prove that the algorithm is good enough, is interesting by any, there should not be so similar algorithm. I know, you know, for instance, the work from Kendall that make a study about the central bias of many algorithms, that they have a title is very nice. The metaheuristic you should never use, and they put a list of many modern metaheuristics that have central bias. Do you think that this type, and there is many recent algorithms, do you think that maybe it's true that the metaphor hides that this is not a good proposal, but mainly the reason is that we don't know in general enforce enough the experimental section that prove that there are innovation in the algorithm or improving the result in any measure, not only fitness, but an interesting aspect like parallelism or something like that? Maybe the metaphor hides that we don't press enough attention to this experimental part. What do you think?
Yeah. I think you raised a very good question, a very good point. Something I haven't talked about, I haven't touched in my talk was I'm critical of metaphor-based metaheuristics, but I don't want to say that everything the rest of the field does in optimization is necessarily perfect science. Some of the proposals that you make are definitely valid and valuable, but I think the entire field has been much too focused on performance, on winning a race of metaheuristic competition against each other. And we're all trying to build a better algorithm than the previous best algorithm. But yeah, we turn it into, some people have called it a horse race. And science is not always about winning some kind of competition. It should be about learning from learning things. For example, if in let's say taboo search, for example, you can have a fixed taboo list or a taboo list that changes with the solutions as a reactive taboo list. Which one of those two works better? I think we don't know that. Even though there's so many papers on taboo search, lots of them with fixed taboo lists, lots of them with variable taboo lists. but we don't know which one is best because everybody is busy building a better algorithm and any information that we have on that is just anecdote. I know one paper in which they tried both, and in that paper this worked slightly better than that. I think the entire focus of the field should move more towards understanding what we're doing and learning from all these experiments in the literature, then building yet another algorithm that is 0.01% better than the previous one. The question is not what is the best algorithm, or at least that's not the whole question. The question is what is the best algorithm and what can we learn from that? What can we take from that and bring it perhaps to other problems or to more general. So I would like to see much more meta research, general type of research in which we study algorithms, but not only algorithms, specific algorithms developed by specific researchers on specific software and hardware for very specific problems, but also more general studies of these meta-heuristic ideas. A taboo search, is it a good idea? Yes or no? Yeah, it probably will work, but how good will it work, etc. Those are questions that we don't have the answer for, and I think we need standardization would be a good idea to be able to compare things better. We need to start sharing source codes, things that people, for example, in a machine learning community, I think people sharing source code is done all over. Everybody shares the source code. If they have a new method, you publish the code on GitHub, everybody can download it, everybody can experiment with it, try it, expand it, etc. None of that happens in the meta-heuristics literature, right? None of that happens in our field. So I'm critical of the metaphors, but I think there's lots of things we can learn ourselves too. And I don't know if I answered your question very precisely, but
No. I think these are many problems also, but this one of the problem is the noise. There's so many proposals, and maybe if we are not so focused on new proposal or not so focused in try to detect new proposals that are not novel, maybe we should focus more on the topic you are talking about. That are really the important topic in the self-field and improve more. Anyway, I'm going to send you, my archive because it's about that. But I think this I made a talk is not so funny as yours because I like it a lot.
Okay.
We have to take that with philosophy because it's a big problem.
Thank you.
Okay. Thank you again.
Okay, thank you very much, Danny, for your question. Any other question from the audience? Any other question? More questions?
It's 5, so I've spoken slightly too long, I think.
It's okay. It was a perfect timing. No worries. Okay, so maybe I can ask you a question. I mean, metaphor-based metaheuristics is not my research field. So I'd like to ask you for good examples. I mean, metaphor-based metaheuristics that actually propose some original and relevant methodological contribution. Can you name any specific proposal like this presented recently? I don't know.
Especially in the early days when there was still room for that type of thing. There's definitely been lots of interesting proposals that originally came from metaphor. I talk about, for example, the whole field of evolutionary algorithms is based on a metaphor, and they must also have gone a bit too far in trying to mimic evolution. But to name a good example for me, for example, is ant colony optimization. And if you ask the original author of ant colony optimization now, I think he will be sorry that he ever called it ant colony optimization, even though it made him quite famous and even, yeah, but now, yeah, he has to live with the fact that he is between the bee colony optimization and the termite colony optimization and the butterfly optimization and the lion and the puma and the etc. But ant colony optimization, for example, the idea is that you have several constructive processes working on building the same solution. So they all build a solution, and then through some specific process, which is inspired by the pheromones of the ants, they communicate about how good their solution was, and then that gives you an idea about how interesting or how desirable each element is for the next round of constructive processes. That was very much an original idea, I think. And it was honestly inspired by the behavior of ants, I think, but it was a new idea. It was not something that had existed under a different name before.
Yeah. Yeah, I was thinking, because I mean, even if nowadays I don't work a lot on metaheuristics, I know ant colony optimization, particle swarm optimization, genetic algorithm, evolution strategies. I was thinking more in, I don't know, recent proposals from the last 10 years. I don't know if you have something to highlight. Not at all.
No, I'm sorry. No, and the problem is there might be something hidden in all of these papers, but how are you going to find it?
Yeah.
Is it the moth that is doing something interesting, or is it the dishwasher algorithm, or and I think it should not be up to the community to decipher an algorithm, and that should be up to the researcher. You're developing a new algorithm. You should be able to show how your algorithm compares to existing algorithms, and that comparison should be made based on the algorithm, not on the metaphor.
Yeah.
Yeah, there's an algorithm based on wolf hunting. So my duck hunting algorithm must be similar. No, that's not how it works. It should be based on the algorithm, not on the metaphor.
Yeah.
Yeah. So I don't know any proposals in the last 10 years that I'd say, oh, this is really an interesting algorithmic contribution.
Okay.
I think in the metaheuristics field, we have also moved on a bit beyond that. I think, yeah, it's going to be very hard to come up with something completely original that is a completely new way of thinking of making algorithms, optimization algorithms. Since there have been so many things proposed, we're trying to fit them together, see what is what, how does this difference from that, can you use this here, etc. It's not about making something completely new anymore. We're beyond that. We're doing more advanced things now. Integration of machine learning. Can you do it automatically? Can you build an algorithm automatically? Yeah, stochastic things, dynamic things, try to make it more practical, try to make it more maintainable, things like that. So the literature has moved a bit beyond trying to find new things. Now it's about doing right the things that exist and then seeing which ones work and which ones don't work.
Okay. And my last question, do you think this trend you have presented today is shared in other research fields that you are familiar with? I mean, if it's particular to this research field, or at least it's particular to this extent, why do you think is that?
Yeah, I've asked myself that same question. Part of it is the things I've already mentioned. We don't share source code. That's not in our DNA. It's about making an algorithm that performs well for a specific problem. And to be honest, I think a part of the answer is it's too easy. It's too, yeah, you don't need anything for it. You can create an algorithm for these simple problems, and it's not difficult. The guy who who developed ant colony optimization. He moved into robotics, and this is also one of the things he said. Now I'm in robotics. If I want to do something, I need a whole fleet of robots, and they're actually need to do things, and I need to repair that, etc. It's much more difficult than spending an afternoon in writing an algorithm and then running it on a few simple problems. So I think our field for that is a bit too easy. And if you combine that with a bubble of people who have decided to not make it too difficult for each other, then I think you get this cocktail. We could here now, we could decide, all of us, if I ever see one of your papers, I'm going to accept it without questions asked. And if everybody does that, we go up in citations, in publications, with respect to all our colleagues in other fields. In your faculty, you will become the best researcher just because you're in a field where people just accept stuff and not make it too difficult for each other. I think this is one of those fields. There's probably many more of them. There's probably also fields where they make it much more difficult for each other, but I think that's also one of the reasons why our field is susceptible. It's a bit too easy what we do, even though we do amazing stuff in optimization, and it's really useful in practice, and yeah, the algorithms we develop for vehicle routing, production planning, etc., are used in software all over the world to do routing and scheduling, etc. But developing just another algorithm with a reasonable performance, that's not difficult to do, and I think that's what also attracts many not so great scientists in our field.
Okay, well, thanks a lot, Kenneth. Well, last chance. Any other question? No? Okay, so, well, I think we can end here this DaSCI seminar. I want to thank Professor Sörensen again for accepting our invitation and for giving this extremely interesting talk. Thank you very much.
Thank you so much for your attention. Happy to be here.
Bye-bye.
Bye-bye.